What I'm going to talk about is how animals reproduce. There are two types of reproduction: sexual reproduction and asexual reproduction. There are 5 types of asexual reproduction. The first is budding.
Budding in Hydra. Hydra, a freshwater polyp, belongs to the phylum Coelenterata. Microscopes have revealed an interesting act of budding in Hydra. Budding is an asexual mode of reproduction which is accomplished quite rapidly. Somatic cells divide to form a protrusion or swelling on the surface of the body called a bud. Let us see how it all happens. Nutrients accumulate at some point near the middle or in the lower half of the body. The cells of the epidermis and gastrodermis divide and form an extension called bud. Gradually the coelentron extends inside. Tentacles also appear as protrusions in the center of which the mouth develops. Once the bud attains a certain size, a constriction arises at its base and the little hydra starts feeding. Eventually, the bud pinches off from the parent. It is said that the bud may help in separation by holding on to an object with its tentacles and then pulling itself away from the parent.
The second is regeneration. And the third is fragmentation. The fourth is parthenogenesis.
Let's go inside one of the most remarkable, most fascinating, and well, most disgusting places on Earth. And we mean that in the best sense of the word. Let's go inside a termite nest, a factory ventilated by air shafts, where termites produce more termites. We're in the queen's chamber, the heart of the nest. Imagine you're the queen. You're attended by millions of sterile worker termites who live to feed you, groom you, and carry your eggs away when you lay them. You aren't acting helpless because you think you need royal treatment. You are helpless. See, a termite queen's head is nearly as small as the rest of the termites in the colony, but she's rendered immobile by her 4-inch throbbing, pulsating egg machine of an abdomen. How many eggs can this body produce? Take a guess. Would you say hundreds a day? Maybe, I don't know, 1,000? A high-performance queen like this one can produce, well, let's do the math. 30,000 eggs in one day, times 365 days a year. That's 10,950,000 eggs. times 15 years the life of a queen, this body will crank out 164,250,000 eggs in her lifetime. No wonder she needs so many attendants. It's one of their jobs to carry all those eggs to cells where they hatch into fragile nymphs. These nymphs will grow up to be more workers whose job it is to continually build and repair the nest, supply it with food and water, and care for the queen. In this termite factory, the Royal Assembly line never shuts down.
And the last is fission.
Not all snakes lay their eggs. In some species, the female retains them within her body until they're ready to hatch, so she gives birth to live young. The marshes of northern Argentina, home to one of the largest of live-bearing snakes, the anaconda. This is a female, and she's heavily pregnant. It's morning, and she's chilly, so she moves out of the water and onto the swamp to warm herself in the sun. Slowly, the day begins to warm up. Now it's getting a little too hot for her, so she moves back to the water to cool off. In this way, she manages to keep her body close to 29 degrees centigrade, perfect for the babies developing within her. But she won't give birth here and now. There are caiman around. At last, she finds the quiet pool that she needs. And her contractions start. The first of her babies has arrived. Up it goes to the surface to take its first breath of air. But there are more babies to come. Eventually, she produces 15. In fact, that's quite modest for an anaconda. They can produce up to 40. Right from the beginning of their lives, they're totally independent, and get no care or protection from their mother.
Only a warm-blooded bird that stays with its eggs and keeps them warm too would have any chance at all of breeding in these conditions. And conditions are getting worse. Temperatures are plummeting. These penguins have journeyed here to find a partner and to mate. Now, inside the female's body, another journey starts. Here in her ovary, the largest of a cluster of follicles has reached maturity and contains an ovum. Most is yolk, food for the new chick. But there's also a nucleus containing half of the chick's genes. When it's released, the ovum begins its journey down her reproductive tract. Waiting sperm swarm all over it, searching for the nucleus. Several get through, but only one can contribute its half of the chick's genes. Now that the egg is fertilized, muscles contract to keep it moving. Spiral ridges force it to rotate so that it can be coated with albumin, the egg white that will provide the chick with water and protein and defend it against infection. Strands of albumin suspend the yolk like a hammock, allowing it to rotate and ensuring that the embryo remains on top, where it can develop safely. Everything is bound together by membranes, but the egg is still soft and fragile. To survive in the outside world, it will need a shell. For months, the female penguin has been storing calcium in cavities in her bones. Now her blood carries that calcium to her shell gland, where it surrounds the egg as a concentrated solution. At seeding points on the fibrous shell membranes, the calcium crystallizes. Entwined with special proteins, it grows to form an eggshell. Finally comes the cuticle, which helps waterproof the egg and gives it its characteristic texture. Now it's ready to be laid. Only by producing a completely self-contained world in which the embryo can live and grow for the next 64 days can these birds create new life in this inhospitable place. But making it has exhausted the female. She needs to find food. She passes the egg to her partner. He takes it into his brood pouch, a pocket that holds the egg just above his feet and next to a patch of bare, warm skin. And she joins the other females on the long walk back to the sea and to food. But it will be months before the males eat again. They're just incubators now. It may seem a strange system, but it works. Because inside its egg, the chick has food when there is no food available nearby, and warmth when outside it's freezing.